Alrighty, guys. So week two, day four, we're getting started with the wonderful world of lambdas and list comprehensions. So there's a couple of concepts that I think we should discuss. The first one is types of code. So that sounds really high level and fuzzy, and that's because it is. But in general, in functional programming, we have two different types of code that we like to talk about. The first one is called declarative code, and the second type is called imperative code. So here, let me add a comment. We'll say declarative versus, okay, let me zoom in, imperative code. Also, is everyone able to read the comments in my VS Code okay? Or is it a little bit hard to read? Okay, perfect. If anyone does have trouble reading it, let me know and I can change the background color scheme. That's not a problem. Also, just in general, if you guys do want to have cool color schemes, you can change that in your preferences for VS Code and go to your themes, and you can set up really cool color themes. Um, they've got some nice options that can make it. I'm a big fan of dark mode, and specific types of dark mode, like the all blues, but you guys can change that on your computers as well. Would not recommend doing it right now because you'll get sucked into color choices, but it is something good to keep in mind. All right, so declarative versus imperative code. So the distinction between declarative and imperative code is the amount of nitty-gritty detail, I suppose, that you provide when writing out when creating pseudocode for your example. So an example of declarative code would be something like um, give me a list of elements, or give me a list that whose contents are all multiples of three of original list. So, if the original list is like 1, 3, 5, your new list should be something like 3, 9, 15, something like that. In contrast, imperative code is far more detailed, I suppose. So that would be instead of just saying, do this, imperative code is something like, create a blank list for each element in the original list, right? Just iterate over each element in the original list, multiply each element in the original list by 3, add that element to the blank list, return the blank list. Now, each of these types of code functionally does the same thing for us, right? You're still getting a list at the end that is giving you the original list times 3. But which type of code is better or more unique? Or I guess more to backtrack, based on how I've written this out, which one looks like it would be shorter to write out and run than the other?
The
I think at
declarative,
first glance that everybody thinks that short sentence should be shorter code at first glance.
B, right? But okay, you're actually all correct. There isn't really anything to circumvent that. But let's see how that works in practice. So now we're going to go through I like to do group exercises. So we're going to all create the code for this imperative use case. So, and then we're going to compare it with the declarative case. So let's create a list. I'm going to call it my list, and we're going to have it be 1, 4, 18, 6. So let's work out the declarative or the imperative case first. So how, well, let's go step by step. So what do I need to do to create a blank list?
Give it a variable equals and then a just the list brackets, the brackets, empty brackets.
All right, so that's my new list is going to be, yep, empty brackets or my list too. Also, a word to something to mention about, I don't know if you guys have gotten the spiel yet about variable naming conventions. Have you guys gotten that?
Not really.
Be
Okay.
specific.
Um, so in general, be specific is the number one thing. Number two is have consistent naming conventions through your code. So there's a bunch of different ways that you can name your variables. You can use camel case, which is what I personally like to do, where you have essentially keep everything in lowercase, but if you have a new word or a new term, make that term uppercase. So this is a new list, is an example of how you could do something in camel case. Or if you're trying to be specific, just looking around my room, what's something we could do? Headphone volume control. Something like that is an example of camel case. Now, you can also just type it all out in lowercase, headphone volume control, but that looks ugly because you can't tell what the differences are between the words. What's the difference between headphone volume control and stereo volume control? These just look like giant flat blocks of text. I can't tell the difference between them without, going and reading them very carefully. The distinction that can be drawn between those is if you put spacers in between, which are usually just underscores. So these are the two main conventions for variable naming that people will stick with in their code. What I would recommend is pick one and stick with it. So if you want to use camel case or snake case, either one is fine. Yeah, I think, Jonathan, what you're saying about using one in one language and the other in the other is totally okay. And honestly, that can sometimes make things easier if you're trying to write code that uses multiple languages to help you distinguish between which one you're using. The other thing I would say is don't switch it up in the middle of a file. So if you're going to pick which notation you're going to use from the outset. The one thing that is very scary to see as someone who reviews code is someone who codes in camel case for the first half, and then they're like, you know what? Let me completely switch my notation and go to snake case, and then do that after. Stick with one, use it for the entire thing. All right. So that's my little ramble about naming conventions, but hopefully that's helpful. Also, oh, one other thing, don't use things that are protected keywords in your names. So, for example, do not say 4 equals, 4 should not be the name of a variable you create. Similarly, even though name is not a protected keyword in Python, in other languages it is. So generally, if you have something that you're like, I don't know if like name or list or for is a protected keyword or not. Number one, there are guides that tell you what protected keywords exist for your language. And number two, if you think it is a protected keyword, just add on some details. So you can say name and then change it to first name or
When you say
full name.
protected, do you mean a reserved word within the language?
Yes. So essentially, or like naming something like true. True with lowercase doesn't mean anything in Python. However, is calling your variable true a good practice? Definitely not. So that's sort of what I mean in terms of variable naming conventions. Take a second to think about how you're naming things, and then if the name looks like something that could be confusing or shouldn't be what you name it, change it and make sure that it's not a reserved word or a protected key. All right, so back to imperative versus declarative. So, all right, we've created a blank list. Now all we need to do is iterate over each element in the original list. So we can say, let's see, how do we want to do that? For item in my list. So we're going through everything in my list. We're going to multiply that by 3. So here we'll say item is item times 3. And then now we need to add that element to the blank. Ooh, this is a good question as well. How can I add elements to a list in Python?
Append.
So what's the format of that? How would you add item to the end of new list?
New list dot append item.
Thank you, Daniel. Yep, so that's it. And then now we have our new list created. Okay, so how many lines of code did we expend here? We have 1, 2, 3, 4 lines of code in order to create new list. What if I told you that instead of doing this in 4 lines of code, we can do this entirely in 1 line of code? Number 1, you probably wouldn't believe me because that doesn't make any sense. And number 2, that also wouldn't make any sense because we haven't talked about list comprehensions. So let's discuss what list comprehensions are and how they work. So I think the easiest way to do it is through an example. So if we're going to convert this to a list comprehension, and say this is going to be for item in my list. This function, or this list comprehension, does the exact same thing as these 4 lines of code. And here's why. So this construction is a list comprehension. So list comprehension. Now, what exactly is a list comprehension? A list comprehension is, I like to say, it's a condensed way to operate on a list in Python. That's the main definition. So instead of using a for loop to go element by element, a list comprehension is a built-in for loop. So the general format of a list comprehension is it does some operation for every element in list. That's really the main thing. So that's why the list comprehension is a perfect use case for declarative examples like this. So what are we doing in this list comprehension? I'm saying is for every item in my list, first iterate through my list, call everything in it an item, and then create an analog to that item where it's multiplied by 3, and then return the list containing all of it. So does that general structure of how we made this list comprehension and how this does the same thing as that, does that make sense overall? Are there any questions about that?
What part of that one is like doing the append part?
So that is done sort of automatically in here. So as the code goes through, so it sort of implicitly is creating a blank list, and then it's appending each of those to it, if that helps.
I see. Yeah, because it's the new list. So on the other one, that was our blank one that we were sort of appending or pushing to. Okay, got it.
Exactly.
Thank you.
Yep. But yeah, good question. Any other questions about the high-level overview of list comprehension before we get into some examples? All right. So now we can make things even more complicated. And here, let me also pull up my console just so we can run this file if we need to. And also, so this is something that I really like to do. There is no penalty for running your code repeatedly. In Python or to some extent in JavaScript. So if you write a piece of code and you don't know if it works or not, print statements and repeated running your code in small segments are your best friends. So let's make sure that we are actually, multiplying my list by 3. So if we run this code, you see here, we have 3 is 1 times 3, 12 is 4 times 3, 54 is 18 times 3, and 18 is 6 times 3. Okay, yeah, looks like our code works. The other thing I would say, in Python and in JavaScript, highly, highly, highly recommend dotting your code with print statements. That way, you have a way to check what your code is doing while you're running it. And also, if your code fails somewhere, that way you have a track record and you know how far it's gotten before it failed and where it could have gone wrong. So print statements are a debugger's best friend. Okay, now that was the debugging rant. So let's move on and get back to list comprehensions. So let's add in a couple more elements. Let's do some other numbers. Okay, so we have now a list of a couple more numbers. Now let's say that we wanted to change our declarative feature to say, give me a list whose contents are multiples of 3 of the original list, but we don't want it multiplied for every element of, let's say, elements greater than 20. So we do not want 3 because 1 is less than 20. We don't want 54 because 18 is less than 20. We do want 38 times 3 or 108 times 3 or 85 times 3, but we don't want any of the other values. So first of all, let's modify our original code in the imperative section to work in that we only want to append things if the original element is greater than 20. So how can I modify this code to do that? Any ideas?
Use a filter.
We could use a filter, but let's take it one step even further back. What is like the simplest way to check?
If statement.
And no. If statement, yes. So let's add an if statement. So we can say if item is greater than or equal to 20, and then we can append it. Now, we can do the exact same thing in, oh, did I say greater than? I said greater than. We'll take out the equal sign. And then, of course, you can have an else, but we don't need an else because we aren't doing anything with it. We can do the exact same thing in a list comprehension. But in a list comprehension, the order is a little bit different. Now we add on an if at the end, and then we specify a condition. So how do we do that in this case for for new list? Well, we add on an if at the end, and then we specify item greater than 20. So yes, I do want to save this and I do not want to close out. So what did we just do? What we're telling new list is, hey, I want you to run this function, multiply by 3 on every element of my list. But I only want you to do that if this condition is satisfied. If it's not satisfied, I don't want you to do anything. So what will this do? This will only append multiply by 3 of the original elements for the elements that are greater than 20. So if we run this code, how many elements should my new list have at this point?
Like what it will return?
Yep. How many elements will be printed out?
3. Or and
Oh.
1 element, I guess. 4.
Evie, let's get a few more ideas before we hit print.
Would it be the whole list? It's just some of them will be augmented?
Expand on that. What do you mean by augment?
Well, because it says for each item in the list, do this to the item if it meets the criteria. So item times 3 for item in list. Okay. If item is greater than 20. So if it's not greater than 20, you're just going to return the number. So 1's not greater than 20, so it just returns the 1.
Maybe. Oh, go ahead, Distill.
Oh no, I was gonna say that too. I second.
But if we're looking at what you wrote line by line, you would have had to put an else return item, right?
Oh yeah, maybe.
Maybe. And this is why we talk about the code before we run it. So now we have 2 ideas of what we think is going to happen. So the first idea is that it'll only return, my mental math is not working this morning, so I'm not going to attempt it. But it's only going to return the elements that are bigger than 20, multiply those by 3. Other idea that some of you guys mentioned is it's going to return the original list, and then where things are greater than 20, it will multiply those elements by 3. Is that accurate, Sean and others who thought the second way?
Yeah, that's kind of what I was thinking.
So let's check. Let's see which of these is correct. So we are printing out new list. So hit run. Interesting. It looks like it's actually the first approach, which is where you're only taking things that satisfy the criteria. And here's why. We don't have an else statement. So we're only list comprehensions are, in my opinion, a relatively simple way in order to do this. They're effectively act as a way to both filter and run a function at the same time. So because we don't have an else statement, what we're telling the list comprehension is you're only running this function on elements that we want. For all the other elements, we don't care, ignore. And if we go back to down here, it'll run, again, that operation for each element in the list only if your condition is satisfied. If your condition is not satisfied, move on to the next element. So that's one of the nice things about list comprehensions is it can be used to shorten your list significantly if you know that there's things that you don't want in there. So, for example, let's say that this is or something that you don't want, and that's less than 20. Oh, sure. Let's say that this is a list of people's ages who are, in attendance of something, and you only want people who are you only want to know the ages of people who are above 21, then that's where this function can come in handy. Because you're only getting, or that's where list comprehension can come in handy, because you're only getting the ages that are above 21. We can do similar things for other criteria as well, but this is just meant to be a high-level overview of what list comprehensions are and why they're useful. So does that sort of make sense so far about how it's a condensed way to go through a loop, to loop through an array, check if a condition satisfied, and if it is, run something. Does that make sense overall? Are there any questions about what the list comprehension truly is before
Can
we
we
move on?
not add a else statement on a list comprehension? If we want to do that, we would have to do it the other way.
I would recommend doing it the other way. Because in general, list comprehensions are meant to be as short as possible. They're meant to do quick fix operations, basically. However, you are correct. You can actually add in an else statement into a list comprehension. So let's see. We have item times 3 for item in my list. Let's see. I need to remember where we placed that actually, because I generally tend, if you have an else, I usually tend to place that in a for loop, but I think it goes after. Let's see. Just want to make sure that I'm doing this right before we move on. So so you can, I think we should be able to add that else to the end. So we could say else, just say like item, we'll just return the original item. Let's see. Bracket was not closed. Should be closed. Let's try this. Okay, invalid syntax. All right, let's try to flip this into here. Okay, there we go. And make sure that that actually works. Perfect. Okay, so yeah, if you want to use a else statement in a list comprehension, then you need to flip the ordering around. And you need to turn it into what's called a ternary operator. So a ternary operator is, I don't know if this is something that you guys have covered yet in the curriculum. I wouldn't think so, but
I don't think we've covered it. I think some of us have like ran into it doing research for challenges, but we haven't covered it in class.
okay, cool. So we can go over that now, because it is something that is very useful for working with booleans. A ternary operator is super simple. It is essentially condensing a if-else statement. So what does an if-else statement look like? You have if, condition, thing. Else is if not condition, thing 2. A ternary operator condenses all of this into one line and it says thing, if condition, else, thing 2. So, for example, let's say that you have like a variable, and let's call it food. Let's say that food is, ice cream. So what we could do is we can create a variable. We can say, is food good? And let's say that food is only good if it is ice cream. So we could say true if food equals ice cream, else false. Okay, that was roughly speaking. That is how you can create a ternary operator in Python. Oh, and that's supposed to be a double equals. So this is the equivalent to saying if food equals ice cream, then is food good equals true, else is food good equals false. So these two statements, or this and that, are both equivalent. They both do the same thing. However, one of them is more condensed than the other. And this is another sort of word of warning that I would give. Ternary operators, list comprehensions, and lambda functions, which we're going to get to, are all very powerful tools. And personally, they're some of my favorite things to have in the coder's repertoire. However, they're only should be used, in my opinion, if you're doing something that is quick and can be easily condensed. You can, create a ternary operator that does the same thing as an if, an else if, else if, else if, else if, da, 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 da. But for that, just use a switch statement. Ternaries are meant to be short for a reason. Similar, for a list comprehension, list comprehensions are meant to apply one function to your list for a certain set of conditions. Do not use a list comprehension if you need to apply one function, but that's conditional on another function, which is then conditional on some other condition, and blah, blah, blah. Just use a for loop. Also, again, remember that it's not very hard to convert from an imperative piece of code, like the one that we wrote out here, to a list comprehension. This, you can write it out in an imperative format and then realize, oh, hey, all of these things are pretty small, simple steps that fit the pattern of what I need to do for a list comprehension. But I can just convert it. There is absolutely nothing wrong with writing your code imperatively and then making it declarative later. So anyway, that was a short summary of ternaries and then imperative versus declarative again. Do you guys have any questions about that before we move to lambda functions? Okay, I'm going to assume that there aren't any questions right now. Okay, fantastic. So let's move on to lambda functions. So what is a lambda function? A lambda function is like Python's version of a fat arrow function. And this is something that I should have asked about earlier when I was doing that pop quiz before class. But does anyone tell me what a fat arrow function is? In JavaScript?
It's almost like a list comprehension. It's just a very shortened way of writing the function, right?
Kind of. That's close. Let's see. It is a higher order function. And okay, Justin, what you just said is a recursive relation. So if you're saying that a lambda function is the same as a fat arrow function, which is the same as a lambda function, we can keep going back and forth with that definition all day. So you're not wrong, but that is not helpful. And that we'll see why when we get into recursion in loops in a few weeks. But does anyone have a more succinct, that's not the right word. All those definitions were very succinct. A definition with an example of when you could use a fat arrow function. Let's see. Eunice, I don't think we've heard from you today. Do you maybe want to give it a shot?
I mean, you can use a fat arrow function with any of the higher order functions, like map or filter.
So that's correct. You can basically use a fat arrow function in order to stipulate conditions for your higher order function. So you can use it to filter by a specific criteria that may be more complicated than just an equal sign. Or you carry out a very simple operation in order to multiply everything by 2 and add 1 or something like that. But fat arrow functions and lambda functions are both anonymous, very, very concise functions. So how do we write a lambda function? Well, I guess how do we write a function in Python in general? Well, the first thing we have to do is say, define your function with the function name. You say function name, and you take in your parameter, then your colon, and then you're going to do stuff with parameters, and then you're going to return result. That's long and kind of cumbersome if I have something that I need to get done in like a line or two. Okay, and my headphones just decided to start dying, so that's fun. Well, worst case scenario, I'll just pop off of these. So if you guys lose me at some point, that's why. If we want to write a lambda function, this is way short. We don't have to use define. We don't need to use that many parentheses. What you can say is I'm just going to call it my lambda is going to be the name of my lambda function. Then you're going to say that this is a lambda function. We're going to specify what our input is. We call it x, and what we're going to do with our input, which is x squared plus 1. That's it. This is the equivalent of saying define my lambda x, return x squared plus 1. Or if we want to be more succinct or more correct about it, return result. This and that are identical in function. However, one of them is anonymous, which is a lambda function, and the other is longer. One of them is way shorter than the other. Does that make sense? Any questions? Yes, Megan, go ahead.
What would be the benefit for having an anonymous function?
Good question. I'll flip the question back on you guys. What is the use case of using a fat arrow function instead of defining a function separate?
It just said it's cleaner and more concise.
Are there any other benefits to it besides it being cleaner and concise?
Kind of reusable.
Okay, yep. Any others?
Memory usage?
Memory usage can be part of it, but these are really tiny functions anyway.
Thank
But
you,
yeah, I
guys.
mean the main benefits are, like as you guys outlined, are really just those three. It's short and you can use it again. That's all. So instead of repeatedly saying, let's say that you know that you need to repeatedly square an array and add 1 to it, instead of copy pasting x squared plus 1, x squared plus 1, x squared plus 1 everywhere, just make an anonymous function to do the job. Now, why do you want to make it anonymous instead of a fully properly defined function? I mean, lambda functions are properly defined functions. It's just written out more shortly. Well, in my opinion, squaring something and adding 1 does not warrant, is the word I'll use. Defining it. It's not the same thing as no. I think it doesn't warrant creating a full actual function for it. So that's the main use case for anonymous functions. Is there a quick, easy fix that you need to repeat a bunch of times? If yes, make it an anonymous lambda function. If not, it's okay. All right. So how can we actually invoke or use a Lambda function? Well, there's a couple of ways that we can do it. We can run a Lambda function. We can invoke a Lambda function the same way that we would invoke a normal function. So what we can say is I could say my lambda of 12. Now this should equal 12 squared plus 1, which is 145. Oh, we should also print that so we can actually see it. And if we run this, oh, here, let me comment out that print statement. Oh, no, I did not want to do that. Let's comment, and we'll rerun it. We see that we do indeed get 145. So what's happening in this lambda function? It's taking my input, it's passing it in as my argument. So, oh, I should also probably say, so lambda argument, colon, and then thing to be returned. That's all a lambda function is. You can only write lambda functions for one-line functions. I believe there may be a way you can do it for things that are more complicated with 2 or 3, but at least in JavaScript there is for fat arrow functions. In Python, you really do not want to do that. And also, again, that goes against the purpose of a lambda function. If it's one line, make it a lambda. If it's any more than one line, make it a regular function. So this is one way that you can write a lambda function. The other is you can directly do it in your functional definition. So if we're defining the lambda function as an anonymous function, like we are here, we can then immediately, so we can enclose the lambda function in parentheses, and then immediately specify our input, which here the input might be 12. And we can rerun that code, and we see it's the exact same thing. So again, lambda functions are meant to be as pithy and concise and easy to run as possible. So again, lambda functions are used a lot as a one-time function, basically. So let's see. What are some examples that we can use? Okay, let's say that we have 3 different lists that we want to do list comprehensions on. And for every single list, I want to run this x squared plus 1 function. How can I do that? So let's say we're going to do it for my list, and then let's say we have run my lambda for my list, and then my list 2, and let's pretend there's a bunch of others. Right? So what we could say is, we could say like new list is going to be my lambda on item for item in my list. Then new list 2 is going to be the exact same thing, because we want to create a new list with it. I'll just say item in my list 2. It's so nice and condensed and simple. Instead of writing out, the whole for loop and then the if statements, and then we say, instead of this, it would be item squared plus 1. No. It's so nice and simple and concise in order to do that. That is the real benefit of lambda functions. If you can condense in conjunction with a list comprehension, you can condense something that would take up a full for loop into a one-line expression that you can reuse a bunch of times. So let's make sure that this works and that I'm not just saying things. But if we check our code, we see that indeed this definitely looks like it is this array squared plus 1, because we're getting a bunch of very large numbers. 37. Yeah, I mean, at least for some of the smaller numbers that I can square in my head, that looks like it's giving the right answer. So that's one of the main use cases of lambda function. The other use case of Lambda functions is you can help to, well, the other downside of Lambda functions is sometimes if you define it, you may forget its definition, especially something like my lambda. What on earth is my lambda mean? No one really knows. This is where comments are extremely helpful. Say what your function does. So generally, I like to do this when I'm defining a function, whether a lambda or a regular function as well. I'll just write down somewhere that my lambda squares the input and adds 1. This is used for array or for list transformations for data processing or something like that, assuming that's what you're actually using. Why is that helpful? Well, let's say that you take a break for a week and you come back to your code later, or you get code with a Lambda function from someone else. You see that they define this Lambda function somewhere. You're like, why did you define this as a Lambda function? This is exactly why. Because you say, here's what the Lambda function is, and here's why I'm invoking it repeatedly. So adding comments to your code about what your function is and why your function does a certain thing, extremely useful. So yeah, highly recommend commenting your Lambda functions and adding good naming conventions to them. See, all right, I think that is really about it for this morning's lecture. So we went through declarative versus imperative functions. Declarative functions are pithy, simple, and get the job done. Imperative functions get the job done, but are broken out step by step by step. A lot of times, if you write something to be an imperative function, or an imperative piece of code, you can convert it to be a declarative piece of code. And we saw that with the long, for loop, creating a new list, appending to the list. All of that can be done really simply in a list comprehension. Now, let's go back. What is a list comprehension? A list comprehension allows you to iterate over every element in a list and run some operation or some function on it, assuming that a condition is satisfied. Now, as I think one of you asked, and I don't remember who, there are ways to use else statements in list comprehensions. However, you need to flip the format of the list comprehension to do that. So what we'll do is, so we have some operation, if condition, else, other operation. And that's if you want to have an if and else. However, again, I do not generally recommend doing that in list comprehension. Now, this piece, the A, if condition, else B, is the same thing as a ternary operator. And that's exactly what a ternary is. You have ternary variable is something if the condition is satisfied, otherwise it's a second. It's an easy way to condense a short if-else statement that ends in the definition of a variable into a one-liner. Then lastly, we talked a little bit about Lambda functions, which are down at the bottom. Again, Lambda function is the exact same thing as a fat arrow function in JavaScript. It is an anonymous function that is a one-liner that you can use for simple operations that you can repeatedly invoke throughout your code. That's the only reason it's useful, is because they're simple. If you name them well, they're obvious, and you can repeatedly invoke them if you need them at any later time. You can combine list comprehensions, Lambda functions, and ternaries together to create some really powerful one-line pieces of code that can define new variables. And that is the main takeaway from today's lecture. That's all I've got for this morning. Are there any questions on your guys' parts before we take a quick break and then jump into problems?
Is there any way you could post like all those notes you just took? Because I've been trying to follow along, but obviously you're jumping around telling us everything. Post all those notes in your VS Code somewhere. Because you
Sure.
got like a
How
lot of
about
like good comments in there that I want to try to get into my notes.
how about in the Golf channel? All right, cool. Just sent those. So also, something else that I recommend, and we can, well, first let me ask if there's any other questions before I jump into a secondary discussion. Okay, if there's no other questions, we're gonna go ahead and stop the recording